Da, 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 da. Oh, hello there. I apologize. I totally had a plan, and then my cat distracted me. Why is it that this little guy right here just kind of came by? I planned on doing a little ditty, but then he got up and decided to basically start going through everything. Jeez, cats really are science.
It's turtles all the way down.
Y'all have been warned. It's computationally irreducible, bro.
Though I know I should be wary, still I venture someplace scary. Ghostly haunting, I turn loose. Beetlejuice! Beetlejuice! Beetlejuice!
Hey guys, what's going on? Memes here. So yes, words are hard, especially if you haven't practiced them. At least in my experience. So, what's actually going on within my experience or that I've observed or heard about in the past few days? Let's take a look over here. Oh wait, what's this? A new theory for systems that defy Newton's third law. What is Newton's third law, you may say? Newton's third law. Formally stated, Newton's third law is for every action, there's an equal and opposite reaction. This statement means that in every interaction, there is a pair of forces acting on the two interacting objects. The size of the forces on the first object equals the size of the force on the second object. Ain't that swell? That's basically what we heard when we were growing up and everything. It's like, all right, I push on the wall pushes me that way because the wall has a greater amount of force. Now, apparently, you could try to punch the wall, and if it's not embraced a certain way, or maybe you don't have enough tensile strength, it would totally break my arm, or you might just go through like the half-inch drywall. I'm just saying that there's a shock, there's a pop, apparently, there's also a crackle and everything. I have no idea if scientists have been trying to troll us for years, because I was trying to make a cat pun earlier as well. Nobody would ever troll throughout history. Now, what else is going on with all this? So, as we go back to our article, here we go. Wait a second. Is that the number one? It's okay. It's okay. It's basically a lot of the same thing. Program my fleet of robots to behave non-reciprocally. That's beautiful. Newton's third law tells us for every action there's an equal reaction going on the opposite way. It's been reassuring for us for 400 years, explaining why we don't fall through the floor. The floor pushes up on us too. Yes, floors are like walls, except we have more gravity going to the floor. It appears to be a reference frame, I hear. Or at least that's what good old Professor Einstein would say. When a system is in equilibrium, no energy goes in or out. Such reciprocity is the rule. Mathematically, these systems are elegantly described with statistical mechanics, the branch of physics that explains how collections of objects behave. This allows researchers to fully model the conditions that give rise up to phase transitions in matter when one state of matter transforms into another, such as when water freezes. Ex- Except apparently we've also discovered a couple other states of water as well. Because, okay, normally you put the ice cubes, you put the water in the ice cube tray, you put it in the freezer. Very often it grows. It grows for some reason. It's like, oh, you put the water in the cup, you put it in the freezer. It grows. However, if you freeze it fast enough, essentially, I am pretty sure it just turns into like a crystalline lattice, they may say. I think that's black ice. Its properties are a little bit different for anyone that's ever driven on black ice. I think it's supposed to snow. Welcome to New England, everybody. Oh, it's okay. It's okay. But all I'm saying is, these are very interesting times. Very exciting times, may say. And I totally was basically quote unquote huffing my own farts when I'm like, oh, look at what's going on with this. It's basically I'm just learning how to sine and cosine and everything. I was getting overly excited by playing with Wolfram Alpha. I totally need to become a numbers guy. Dang you, Thad! Now, But many systems exist and persist far from equilibrium. Perhaps the most glaring example is life itself. Now we're getting a little philosophical. I'm totally with it. We're keeping out of equilibrium by our metabolism, which converts matter into energy. A human body settles into equilibrium is a dead body. That's very sad. That's very sad. See, I like to think of it as like homeostasis. It's like you're in that zone where it's like, all right, you're not starving, you're not too full, you don't have excess things in your body, and you have enough rest. I think that's what most people try to do. I see you there, Bone. Oh, welcome, my friend. I see you're in your cat hiding state. It's a very good thing for you. I like cats. But as we can also continue onward, in such systems, Newton's third law becomes moot. Equal and opposite falls apart. Imagine two particles, said Vincenzo Vittelli, a condensed matter physicist at the University of Chicago, where A intersects with B in a different way and how B intersects with A. Such non-reciprocal relationships show up in systems like neuron networks and particles in fluids, and even on a larger scale in social groups. Predators may eat prey, for example, but prey doesn't eat its predators. I thought that's what the circle of life was for. Because eventually that lion eats the gazelle, but then that lion eventually passes because it's in equilibrium, goes back to the earth, and then the gazelle eats the grass. At least that's what they told us back in the day, and I'm pretty sure that's actually true. How you want to conceptualize it, that's totally your opinion. It's totally up to you. I'm just saying. For these unruly systems, statistical mechanics fall short of representing phase transitions. Out of equilibrium, non-reciprocity dominates. Flocking birds show how easily the law is. It's the birds. Birds do bird things. But essentially, I wanted to show you the spin liquid. That's what we were saying. Is this okay? I think I opened up something else. Okay, no, this is another condensed matter phase. I apologize. Quantum simulators create a totally new phase of matter. This is also brought to us by Quanta. One of the first goals of quantum computing has been to recreate bizarre quantum systems that can't be studied in an ordinary computer. Dark Horse Quantum Simulator has now just done that. Ooh. Look, it's got arrows and angular momentum thingies. Yes, a quantum spin liquid can form when atoms are placed in triangle-like Kagome lattices. You mean kind of like the hexagonal things with the bilayer and trilayer graphene we were talking about last week? It's a wonderful time to be alive. We are blessed for those that are still with us. We can honor the past. Quantum computers, enthusiast forecast, will one day work. I love how that was phrased. Work no end of miracles, from breaking digital encryptions to designing wonder drugs. At this early stage, however, the advantage of many quantum algorithms remains speculative, and some researchers wonder whether wielding necessary control at the subatomic level is even possible. It's a very daunting goal, says Marcus Grainer, physicist at Harvard University. Yet, even without full blown quantum computers, physicists are creating related, more specialized types of machines, quantum simulators, to realize one of the initial aims of the field: to eliminate the Byzantine behavior of quantum systems. How dare they? I'm just saying, isn't the whole point of like a lot of the quantum computing is like, we also want to figure out what's happening in the quanta. If we could just figure out what's going in the quanta, can we reverse engineer it? Is it computationally equivalent? That was one of the things I was kind of trying to say. Computational irreducibility. Those flow off the tongue a little weirder. As Richard Feynman would put it in a 1981 lecture, nature isn't classical, damn it. And if you want to make a simulation of nature, you'd better make it quantum mechanical. I like Professor Feynman. If you've seen any of my other videos about it, Over the past few years, groups in Paris and Cambridge, Massachusetts have made great progress to this end using a dark horse type of quantum simulator. They've made a series of simulations that would take months or more to replicate on a classical computer. They've been exploring some of the frontiers in physics, said Ivan Dush, a pioneer of the technology currently at the University of New Mexico. May I just point out, we're talking about quantum computing, and they're talking about physics. It's all connected. I see you there. Oh, welcome Yvette as well as Grizz. I see you there, Jen. Welcome. You are one of my senpais. But as well, this is the thing. It's like, don't worry, it gets better. It gets better. Actually, going back and listening to some of Thad's things, I'm like, these things are starting to make sense. And I was trying to find the article. That's what took me so long to get started. I was trying to find it because I put it in Wolfram Alpha, and I'm looking at the model. I'm like, okay, no, this is what they're doing. I'm like, we can do this at home now. You don't need to get that fancy chemistry set and almost burn down the house like back in the day. We can start doing this virtually. I think that's pretty rad. I think we should bring that back because I think we're going to be using it a lot more. I'm just saying. Today, the Cambridge Group unveiled their most significant discovery yet, the detection of an elusive state of matter, known as quantum spin liquid, which exists outside the century-old paradigm outlined in the way in which matter can organize. It confirms a nearly 50-year-old theory predicting the exotic state. It also marks a step towards the dream of building a truly universal quantum computer. I can hear all the engineers now. They seem very excited. If I take the entire history of an ultra cold atomic experiments, it would probably be one of the most impressive and groundbreaking experiments in the field, said Ehud Altman, a condensed matter theorist at the University of California, Berkeley. I I'm just saying great things are going to be coming from Berkeley. Keep your eyes on it. Just saying. Staying neural, the new work uses a novel approach to quantum computing based on neutral atoms. Although the method has lagged behind more popular quantum computing technologies such as superconducting circuits or trapped ions, I think they use some of the vacuum. At least according to one of the Wolfram streams, he had one of the guys on. It's like, at least right now, more of the analog systems seem to yield greater results. Why? Well, we know that technology better. We've done it before. The digital things, you gotta work through some other things. It's all right. We can figure it out. But neutrons have special properties that have long captured the imaginations of quantum engineers. Oh, look, abstractions. Apparently, these are important. Some may say derangements are also important. The key to building a quantum computer is to assemble a collection of qubits, quantum objects akin to classical bits to satisfy two contradictory requirements. The qubits must first be firewalled from the outside world. You don't want none of that bad juju getting in there. I think they actually may have said it in one of these articles. But neutrons bound, excuse me, blah, blah, blah. Otherwise, vibrations of heat will destroy the. Okay, mojo. I apologize. I was culturally appropriated. If they must also be simultaneously be accessible and manipulable. Gotta have access to it. Neutrons balance these demands especially well, proponents say. Laser beams can capture and move atoms like a tractor beam, protecting them from the external interference. An additional laser pulse can puff up atoms into a supersized Rydberg state, akin to flipping on a classical bit. These neutral atom qubits can assume superpositions of being large and small at once, and also connect with one another remotely through entanglement, the two essential ingredients for quantum computing. Now, where was the Rydberg pairs? I just because I thought this was pretty interesting. Bacteria-sized molecules created in the lab. Link sees them as could play a role in quantum computing. Where is it? Yes. The scientists have created giant molecules the size of bacteria that may be useful in future quantum computers. The molecules of unusual size are formed from pairs of Rydberg atoms with an electron that has been boosted into a high energy state. Such electrons orbit far away from their atom's nucleus, and as a result, can feel the influence of faraway atoms. So basically just lowered it down a heck of a lot, basically to just above absolute zero. All right. Ba, ba, ba. Oh, look, yeah, they formed, at least within a thing. Looks like the Eiffel Tower. That was a Paris group doing some work. It was important to them. Now, we're talking about 256 qubits versus 150 qubits, Touch says. That really matters. That's a large, like 150%. Researchers have been using these grids of neutral atoms to probe phases of quantum matter. They're like familiars, phases of liquid and solid, but with more exotic, complicated configurations, enabled by throwing superposition and entanglement into the mix. The exploration of quantum phases is a fundamental pursuit, but there's also practical applications, such as understanding what causes high temperature superconductivity. Now, aside from just reading that, again, I am not a formally trained physicist. I am a dude on the internet wearing a shirt. What does this sound like to me? Well, if you got the electron further away from the actual, like, I don't know, nucleus, there, might it be more free to interact with other things so that rather than having to get to a certain level, it's like we might be able to detect, because apparently the exchange of electrons just seems to what cause a lot of different chemical stuff and things to happen. If we can start to detect that better by being in a slightly differentiated state, I think we might be able to map things out a wee bit more. I have no idea. I have no idea. Well, all I know is I played Ark Survival Evolved, Grizz. That was a very good game. I highly enjoyed it. After our war with the Chinese, we ended up conquering server 438, 439, one of those. And again, the main PvP guild totally did it. Then they kind of got bored, and then we conquered the rest of the map. We have to be honest about these things. We didn't do it alone. Condensed matter physicists study such phases using crystals found in nature and what they can grow in their labs. But neutral atoms researchers can flexibly program their matter, precisely positioning their atoms into lattices of any shape and engineering a bespoke atomic interactions through the manipulation of Rydberg states. Now, I'm just saying that if you could literally do that with anything, isn't that kind of like a 5D printer? That kind of sounds like a replicator to me. And again, it's baby steps, baby steps. These are very exciting times to live in. Where's the fun? Okay, in 1973, Philip Anderson, a condensed matter pioneer and eventual Nobel laureate, predicted that matter might enter a bizarre state called quantum spin liquid. Many atoms have the quantum property known as spin, which defines a direction. Spins interact magnetically, which can make them tend to a point in opposite directions, especially at low temperatures. But if three atoms are arranged in a triangle, because apparently triangles are important. Somebody asked Professor Wolfram about that. I don't know if I clipped it yet. But if three atoms are arranged in a triangle, only two of the three can point in opposite directions. Therefore, a triangle-like lattice of atoms can't freeze into tidy patterns of spins. Even at absolute what? Even at absolute zero, spins continue to fluctuate, analogous to how atoms slosh in a liquid. So one of these articles say it's, I don't know. I think somebody just came up with it. Like, it's totally not like an actual liquid, but I'm like, continue to fluctuate, analogous to how they slosh in a liquid. I'm just like, it kind of sounds like the same thing. I don't know. Nobody would ever be contradicting you on the internet. Quantum swim liquids experience a lot of entanglement. That feature leads to topological order because individual particles can sense the system's overall topology. Why is the infinity groupoid popping in my head? I have no idea. What does it look like? I don't know. Maybe something like this. The atoms at the punch a hole in an ice cube, and it stays frozen. But remove the atoms at the center of a quantum spin liquid, and that system's properties could change. You remove the center of any liquid, that's going to change stuff. But the quantum spin liquids in a novel class of matter. Various groups have seen indirect hints, blah, blah, blah. Okay. So all I'm saying is, so apparently we're using light to basically adjust the spin, which is responsible for magnetism within these Rydberg states of these different atoms. Okay. Now, I just find it interesting that we have that. Okay, I'm actually need to stop doing that. But okay, we're using light to affect magnetism. At least that's the gist of what I'm getting from that. So, if we're using light to affect magnetism, what's this? The part that actually met the show the other day. Continue.
Experimentalists, there are two things that are relatively easy to do. One is you can establish some electric field that points from one layer up to the top layer, right? So I'm going to put some gates here, and then I'm going to put them at some potential, and I'm going to create some potential that goes throughout the layer like this. And the other thing you can do is you can put a magnetic plane in, a magnetic field in plane of the sample. Okay. So this breaks the mirror symmetry because I put the magnetic field has this handedness, right? And when I do the mirror, it flips, right?
Now, again, I am not a professionally trained physicist. I'm a dude on the internet. But it kind of sounds like to me he was talking about using magnetism or magnets, utilizing the knowledge of how magnets work, we believe, and adjusting the flow of electrons and what's going on. Now, electrons have a charge, but I thought they were also a wave. I'm just saying, if we can use magnets to potentially affect waves or things that I don't know. There seem to be some reflections here. I'm just saying, multiplication and division, addition and subtraction, they're mirror images. I remember Thad also said that. And again, people have known this for years. I think that's sort of like Gauss's or theorem or something like that. It's like you're looking at these symmetries. I can neither confirm nor deny exactly what's going on, but all I know is from all the random clips of different people I have saying things. I'm just
world
saying
exists on the top of a giant turtle.
That is one of my favorites. I'm just saying this is absolutely fascinating times that we live in. The sheer tools that we have. People like the universe sandbox. Why haven't I need to pay other bills and do other stuff and things first. It's a good thing my cat disrupted me, so now I can probably actually do them now. And I also need to make dinner, and then we got to rank the Harry Potter movies on Tim Possible's channel. Why? Because we can. But just to wrap up real quick, we'll just pop back over to our little window over here, and we'll go back to where was this? Oh, yep. The vortices within the graphene, I believe. Yep. They just seem to just keep popping up everywhere. I'm just saying, look at all those pretty pictures and everything. Again, I realize it's just pretty pictures, but a picture's worth 1,000 words. If you throw some text on it, does that raise the exponent? I have no idea. I see you there as well, Linux. Thank you all for joining. Peace out, everybody. Be safe. And you still got to remember. Come on and get your log. Everyone needs a log. Come on and get your log. Everyone needs a log. Log from Blammo. Logs are important. Thank you, Jen. Peace out, everybody.
Have you guys checked out the Memes of Destruction's channel? He's an interesting dude. I like him.